What if one evening you stepped outside, looked at the sky, and saw something that wasn't supposed to be there? A faint, glowing smear of light drifting among the stars, an object no one had predicted, one that even the most advanced telescopes and surveys failed to catch. Would you feel awe or unease? Would you wonder what else the cosmos is hiding from us, waiting to reveal in its own time? This is exactly what happened when Comet Swan R2 burst onto the stage in September 2025. Until then, it was a ghost, an invisible wanderer coasting silently in the void. No survey had flagged it. No data hinted at it. Astronomers assumed the skies were, if not completely under control, at least predictable. Swan R2 shattered that illusion with a single violent outburst that turned it from a dark rock into one of the most watched objects in the heavens. It raises a haunting question. If a comet this close could escape our gaze, how many others are still out there, unseen, waiting for their moment? A visitor that escaped detection. The mystery of Swan R2 begins with what it did not do. It did not appear in any of the databases built by the great sky surveys. Systems like Pan-STARRS and Atlas spend every night sweeping the heavens with automated telescopes, recording faint dots and tracking their motion across the background stars. These programs are incredibly effective at spotting near-Earth asteroids, small bodies that move in predictable ways. But comets are not asteroids. When they are far from the sun, they are nothing more than lumps of ice and dust. They reflect little light and move quietly, too dim to be noticed unless they flare up. That is precisely what made Swan R2 so elusive. For months, maybe even years, it drifted through the solar system in silence. It wasn't bright enough to be flagged by survey algorithms. It was in effect invisible. Then in mid-September, it erupted. Sunlight had seeped beneath its crust, heating hidden pockets of volatile gas until pressure built and the surface finally ruptured. In moments, dust and ice spewed into space, forming a glowing envelope around the comet known as the coma. That coma scattered sunlight like a beacon. Suddenly, Swan R2 was impossible to ignore. Overnight, it had transformed from a nameless fragment into a cosmic headline. The science of an outburst. To understand why Swan R2 captured so much attention, you have to understand what an outburst really means. Unlike a volcanic eruption on Earth, cometary outbursts are quiet, almost delicate, yet no less dramatic in effect. A comet's nucleus is fragile, a loose snowball of ices, water, carbon dioxide, methane, and other frozen gases, mixed with dust and rocky debris. When it is far from the sun, that mixture is locked in place. But as the comet swings inward, solar radiation penetrates the crust. At first, nothing seems to happen. Pressure builds slowly. Small jets of gas might seep out. But then, at some weak point, the balance tips. A pocket bursts open, blasting dust into space and releasing a flood of sunlight-reflecting particles. For Swan R2, the result was immediate and stunning. The coma inflated to tens of thousands of kilometers across. The comet brightened by several magnitudes, so much that it leapt from invisibility to being visible in binoculars almost overnight. And it glowed green, thanks to gases like cyanogen and diatomic carbon fluorescing under ultraviolet light. To the human eye through a telescope, it looked like a soft disk with a thin tail streaming away from the sun. To scientists, it looked like a treasure chest cracking open. Each outburst is unpredictable because it depends on the comet's hidden interior, something no telescope can see. Some comets erupt once and then fade, as if they've spent their reserves in a single breath. Others burst again and again, revealing new layers of volatile material each time. Swan R2 has already shown erratic behavior, with spikes of brightness that don't follow a clean curve. That suggests its nucleus is riddled with fractures and uneven pockets, a fragile object in constant flux. The road across the sky. Once the comet was spotted, astronomers wasted no time charting its path. Unlike the steady movements of planets, comets trace quick, restless arcs across the constellations. They never linger long in one place. Swan R2, after its eruption, was first seen near Mars in the bright star Spica. By October, it was brushing past Libra's brightest stars, and by mid-month, it cut across the realm of the Eagle Nebula, home of the famous Pillars of Creation. That was more than coincidence. It was a gift to skywatchers. Imagine a wide-field photograph of the comet's green halo drifting past one of the most iconic cosmic landscapes. Few comets ever crossed such dramatic scenery, and astrophotographers around the world knew they were witnessing something extraordinary. The challenge of seeing it, but catching Swan R2 isn't always simple. Its position low on the horizon after sunset means twilight often washes it out, and trees, hills, or buildings can hide it entirely. The best viewing comes from open horizons, seashores, wide fields, rooftops clear of obstruction, and timing is everything. Too early, and the sky is too bright. Too late, and the comet has already sunk below the horizon. The sweet spot is about 45 minutes after sunset, when the twilight fades but the comet still hangs above the skyline. Even then, the naked eye may only catch a faint smudge under dark skies. Binoculars transform the view, revealing the coma as a round glow, and on clearer nights, the faint sweep of the tail. Small telescopes provide more detail, but their narrow field can make comets feel less grand than they really are. Wide angles often capture their essence better. The sense of something diffuse and ghostly suspended among the stars. And for photographers, Swan R2 is a dream. A 10-second exposure on a camera mounted to a tripod reveals the tail, even when your eyes can't. Longer exposures bring out the ghostly green tint and the fine dust structures, and when framed against constellations or even the Milky Way, the images look like art. Fragile beauty. Behind all the spectacle lies fragility. Comets are not robust worlds like planets. Their surfaces crack easily. Their cores are loosely bound. Each eruption weakens them, sometimes catastrophically. Comet Ison in 2013 was expected to become one of the brightest comets in memory. Instead, it crumbled into dust as it passed the sun. Shoemaker Levy 9 broke into 20 pieces before colliding with Jupiter in 1994, leaving dark scars in its clouds. Swan R2 may dazzle for weeks, or it may disintegrate tomorrow. Already its sudden outbursts hint at instability. If its nucleus fractures, the comet could break into multiple pieces, spreading into a wide, diffuse glow instead of a compact core. To photographers, that would still be beautiful. To casual observers, it might mean disappointment as the comet fades faster than expected. The uncertainty is part of the fascination. Watching Swan R2 is like watching a tightrope walker. Every step could end in triumph or collapse. More than science. For thousands of years, comets were not science at all. They were omens. Ancient Chinese records link them to disasters and dynastic upheaval. Medieval Europeans saw them as fiery swords, harbingers of war. Even in the 20th century, fear remained. When Earth passed through Halley's Tail in 1910, rumors of poison gas filled newspapers. Sales of gas masks and so-called comet pills spiked. People sealed their windows in panic. At the same time, comets have always carried wonder. Hale-Bopp in 1997 burned in the skies for months, visible even from cities, awakening millions of people to astronomy. In 2025, Swan R2 carries both legacies, the ancient awe and the modern marvel. It has already earned nicknames online: the Green Visitor, the Ghost Light. TikTok videos teach people how to find it. YouTube streams broadcast its journey in real time. Amateur astronomers in Australia share images that teenagers in Canada can see seconds later. For many, their first sight of Swan R2 isn't through binoculars, but through a phone screen. And yet the experience is no less communal. In the past, comets were feared as signs of doom. Today, they are shared moments of wonder, stitched together across continents, cultures, and timelines. The questions that remain. Swan R2 is a reminder that the universe still keeps secrets. In an age of satellites, automated surveys, and supercomputers, something as large and spectacular as a comet can still sneak up on us. It makes you wonder, how many more wanderers are hiding out there, waiting for their moment to blaze? How many icy travelers are coasting unseen on the edge of detection, preparing their own sudden entrance into our skies? Perhaps Swan R2 is only the opening act. the first surprise in a season of cosmic visitors. Or perhaps it will remain one of those rare, fleeting wonders, remembered as the ghost that appeared without warning, dazzled the world, and then slipped back into darkness. The only certainty is this: for the brief weeks it graces our skies, Swan R2 is writing itself into our story. It is a reminder of fragility and beauty, of unpredictability and discovery, of how much the universe still has left to reveal. The question is, will you be there to see it? Thanks for watching. Don't forget to like and subscribe to our YouTube channel.